Hello, my fifth graders. Today we are going to be um, dividing and simplifying fractions. Not dividing, but simplifying fractions. So our lesson today is how to simplify fractions or reduce fractions. And to do that, we are going to use a flowchart. Now, a flowchart basically is you start at the first question. If it's a yes, go here. If it's a no, go here. And you keep going until you're done with the flowchart. So I'm going to do my best to make it exactly a page, and you know how hard that is for Miss Gorman. So reducing fraction flowchart. Now there is a reason why we do reducing fractions after learning about the rules of divisibility, because there's going to be a few of these that are definitely utilizing those rules of divisibility. So for reducing fractions, the first question we ask ourselves, and when we ask ourselves a question, I make it a bubble. So the first question is, are both numbers even? Why do you think I'm asking that question to myself? Are both numbers even? That's because if both numbers are even, yes, that means I have a job to do. Divide both by 2. So, thinking to myself, are both numbers even? Is the numerator and denominator even? If yes, divide by 2. Then I go back. Are both numbers still even? If yes, divide by 2. And then go back. Are both numbers even? Eventually, you're going to hear the word no. No, Miss Gorman. Both numbers are not even. And then we come to our next question. Can I divide by 3? And I'm going to think that to myself. Can both numbers be divided by 3? If yes, guess what? Divide by 3. Both numbers be divided by 3? If yes, divide by 3. Then ask your question again. Can both numbers be divided by 3? Eventually, you're going to hear the word no. No. Both numbers can't be divided by 3. Then we go to our next rule of divisibility, and it's not 4. Because if a number was divisible by 4, it's probably also divisible by 2, and that would have been taken care of here. So the next one we actually go to is 5. Can I divide by 5? And if I was being specific, I would say, can I divide both numbers by 5? But I'm being lazy. So I'm just going to say, can I divide by 5? Can I take both top and bottom numbers and divide by 5? Guess what? If yes, what are you going to do? You're going to divide both by 5. If you get a yes here, you then just divide both by 5. And you ask yourself again, can I divide by 5? Eventually, it's not going to end in a 5 or a 0. And you're going to say no. You know what? No, I can't. I can't divide by 5. So then you ask yourself, can I divide by 7? Are you seeing a pattern here? I hope so. We are almost done. I don't go through all the numbers. Can we divide by 7? If yes, do it. This is what I do. This is exactly what I do when I'm simplifying numbers. I look at them and I ask myself these questions. Are they both even? If they are, divide by 2 until you can't divide by 2 anymore. Sometimes that takes us a while. Sometimes I see it right away, like, oh, I'm just going to divide by 8. But eventually I'm going to get to small enough numbers. Divide both by 7. Okay? And then you ask yourself again, can I divide by 7? What about no? What if I said no? This is kind of the last one. Can I divide by 11? Notice how these are kind of like those prime numbers, and that really, I know my thing there. It really has to do with the fact that they are prime. So if yes, divide both by 11. Sometimes it's 13, but we're not going to go to 13. So yes. And then you ask yourself again. Sometimes it's no. And now my flowchart is going all the way over here. No, 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 no. These last questions I usually will ask myself because if I get a yes here, that usually means it's simplified, right? If you get a no here, you're probably simplified. Other questions I ask myself, so I'm going to put probably simplified. Probably. Some other questions I ask myself, are both prime? Because if they're both prime, like 5/13 or 2/13, if they are both prime, both top and bottom numbers are prime, then done. There's nothing you can do. Are both of them prime? If they're both prime, they are simplified. Okay, next question. Is the numerator 1? If the numerator is 1, you're done. You're done. So like 1/8, that is as simplified as it can get. 1,000,001, that is as simplified as it can get. If the numerator, the number on top, is a 1, you're done. It's simplified. Okay. The final question is numerator 1 less than denominator? If the numerator is 1 less than the denominator, it is simplified. So 11/12 simplified. 9/10 simplified. 3/4, 5/6. All of those are simplified. If the numerator is 1 less than the denominator, that's as simplified as it can get. So these are 3 questions that I ask myself, and this is how you reduce fractions using a flowchart. So you start here. Are both numbers even? Yes, divide by 2. No, move on. Can I divide by 3? Yes, divide by 3. No, move on. Can I divide by 5? Can I divide by 7? Can I? And then these 3 questions. I really do ask myself. I'm not just saying that. And I have a degree in math, you guys. I have like a math degree. And I still ask myself this flowchart because it works. It will tell me if my numbers are simplified, if my fraction is simplified. This does work. Now, the other way that we simplify fractions is using the greatest common factor. Now, we haven't really talked about factors, so we're going to do that now. My GCF, greatest common factor. And what that is how we break apart the numbers. A factor is the 2 numbers multiplied together, right? So if I have the number 32 sixtieths, right? And I needed to simplify that using the greatest common factor. Step 1 is list all factors. Step 2 is divide by the greatest. So for 32, the factors of 32 is 1 times 32, and I always do it this way. I start with the 1, and I put 32 at the other end. 2, and I know it's divisible by 2 because it ends in an even number. 2 goes into 32, what is that, 16 times? Great. Can I divide by 3? No. 4? Yes. 4 times 8. 5? No. 6? No. 7? No. And then I'm at 8. So these are the factors of 32. Now we're going to do 60. The factors of 60 are 1 times 60. 2 times 30. 3 times 20. 4? 20, 30, 40, 50, 4 goes in 4, 5, 6, 20. Yeah. 4, 5, wait, 15. 5 times 12. 6, I'm running out of space. 6 times 10. 7, no. 8, no. 9, no. And we're to 10. Perfect. So these are the factors. Now, what factor is the largest one they have in common? Well, they both have 1s, they both have 2s, and they both have 4s. So the greatest common factor of 32 and 60 is 4. So I'm going to take 32 and divide by 4, and I'm going to take 60 and divide by 4, because whatever I do the numerator, I must do the denominator. 32 divided by 4 is 8. 60 divided by 4 is 15. And because I divided by the greatest common factor, that is simplified, 8/15. All right. I'm going to pull another piece of paper and show you an example. Paper. Paper, paper, paper. Paper is up here. Just gonna use this random piece. So if I had the fraction, and I need it on a separate piece of paper because I want to use my flow chart. If I had the fraction 20 over 32, and I wanted to reduce this, I could use my greatest common factors. I know it's 1, 20, 2, 10, 3, no, 4, 5. Okay, 32 is 1, 32, 2, 16, 3, no, 4, 8, 5, 6, 7. Okay, so again, it's going to be 4. The other way to do this is to use the flow chart. So, are both numbers even? Yes, I'm going to divide them by 2. 20 divided by 2 is 10. 32 divided by 2 is 16. I ask myself again, are they both even? Yes, so divide by 2. 10 divided by 2 is 5. 16 divided by 2 is 8. And I ask myself, are both even? No. Okay. Can I divide by 3? No. Can I divide by 5? Well, the first number, but not the second number, so no. Can I divide by 7? No. Can I divide by 11? No. It's probably simplified. So my answer is 5/8. That is how you use the flowchart to reduce fractions or use the greatest common factor. We're going to practice more in class, and you will have some independent practice on your own. Have a great day, you guys.